For this experiment, we are to determine the coefficient of kinetic friction between a moving object that has a piece of felt taped to the bottom, the coefficient of static kinetic friction between that piece of felt and the metal ramp that it is running on. In order to determine this coefficient of kinetic friction, we use Newton's second law along with log or pro to determine acceleration by measuring at a scale and using that scale to determine data points on a position versus time graph.
Alright, so our lab in Logger Pro, what we did was we took a video of this cart going up the ramp, and as it's going up the ramp, these blue dots right here represent each frame that goes by that the cart is going up the ramp, and then we also did it as it's going down the ramp. So what we had to do to start off was we took our video, and then this origin right here, we had to change it since we took our video from right to left instead of like everybody else did from left to right. We were getting negative numbers, so we had to flip this origin around. And then secondly, what we did was we set a scale. So our scale is 0.5 meters. And this helped us determine how far our cart went up, which was 0.6405. And this is the different number than what we had. And what we did was, as this cart goes up, we plotted these points, which gave us our points on our velocity time graph. And this velocity time graph, what happens is at time 0, it's gonna have two different slopes. So this first part, you're gonna have a slope of 0.3443, and to find the acceleration of these two values on the both sides of the slope, you have to double it. And this should give you 0.6886, and on the other one should be 2840. And this, the reason we did this is we had to measure the slope on this first half, and we fit it right here with our quadratic function, and it gave us this number right here. And what we had to do was, from our first original plot graph we had, was you get this right here. And since ours wasn't set to 0, we had to change our x and y axes to fit this function right here. And that's how we set it to 0. And these are the meters that it goes up to 0.6. This is where it hits the max and goes back down. And then as you can see that these two slopes are completely different is because the reason that this one's a lot higher than the other one is because that's when we pushed it up, and then once it hits its peak at time 0, that's when this second slope comes in, because as it's going back down the ramp, it takes its own weight of the cart to speed it back up, back to the bottom. And now we shall move to the math.
To find the coefficient of kinetic friction, we first have to use Newton's second law to find the acceleration both going up and down. For going up, we start by doing a free body diagram which illustrates the many forces acting on this cart, including friction, which pulls it down the ramp in the positive x direction. We have the weight that also pulls it down the ramp. And then we have the two y forces, which is the normal force and the weight that pulls it straight down. So for the y forces, we have the normal force and the weight cosine of the angle, which is equal to 0 because according to our coordinate axis, this thing is not accelerating in the y direction. So we can set all that equal to 0 and get the normal force equals the weight cosine of the angle. In the x direction, we have two main forces here. We have the weight of the cart pulling it down the ramp, and we also have friction, which also pulls down the ramp because the initial velocity is going up the ramp. Acceleration going up is negative, but is also in the negative direction, giving us a positive acceleration. If we substitute in our values, we get mass times gravity for the force times the sine of the angle, which gives us the weight, plus mu times the mass times cosine of the angle, which gives us our frictional force in terms of mu times the normal force, which is equal to ma. Now, m's will cancel, and we get to isolate a going up the ramp.
Now that we have found the acceleration going up the ramp, we need to determine the acceleration as it goes down the ramp. So we use the sum of the forces in the y direction to equal the normal force minus the weight of cosine theta, and that needs to equal 0. So because they equal 0, we can pull the weight of the cosine to the other end of the equal sign and have the normal force equal the weight of cosine theta. So and then the sum of the x direction is w sine theta minus friction to equal the mass times the acceleration in the downward direction. So mg sine theta minus mu g sine theta.
Alright, so for a recap, to find the coefficient of kinetic friction, we need to find the acceleration of the object going up the ramp and going down the ramp. For going up, the only two forces here are weight and friction, both of them pulling down, saying that the initial velocity is up the ramp. So using Newton's second law for both the x and y, find the acceleration going up. Basically the same process for going down, and we get a slightly different equation for going down.
In order to find the coefficient of kinetic friction, we take the formula of from the cart going up as g sine theta plus mu g cosine theta, and then we take the equation as the cart went down the ramp as g sine theta minus mu g cosine theta. So from the given equations, we need to subtract the two to get rid of g sine theta. And by doing so, we get AU minus AD, which equals 2 mu times g times cosine theta. And then from the triangle, we can figure out what our cosine theta is by using cosine equals x over r, with x equaling 0.6379 and r equaling 0.6405. And all of that equals 0.99532. So in order to find the coefficient of kinetic friction, we need to isolate mu by dividing by 2g cosine theta. And whenever we do that, we'll get AU minus AD over 2g cosine theta. So now we get the accelerations that we retrieved from Logger Pro, and we get AU equals 0.6886 and AD equals 0.2840. And then we know that G equals 9.8, and then we found cosine theta to equal 0.99532. So now we'll take all of our known values and plug them into the equation and finally solve for the coefficient of kinetic friction. And that is 0.6886 minus 0.2840 divided by 2 times 9.8 times 0.99532. And by computing this equation, we get the kinetic friction coefficient to equal 0.0207.